All right, hi guys. We are going to talk about a little bit of a review for measurement, density, and graphing today. So what is measurement? So something that you guys probably do all the time. If you've ever built something or you've ever worked on something in maybe art class or a science or math class, this is stuff that you guys have been doing since you were little kids. But we're figuring out the size, amount, or degree of a thing by using an instrument or a device marked in a standard unit. So that means like using a ruler for something. We could be using an instrument like a thermometer to measure something, or we could compare it with an object of known size. So in our classroom, we have these floor tiles, and the floor tiles are 12 by 12. So I could lay something on the ground and compare the size, but I'm using something that we know the size of to measure something else. So a measurement is a type of observation that doesn't require a person. So we use this example a lot in weather. We can have weather being monitored constantly, and then there doesn't need to be a person sitting there to do that. So you can have a weather station. Weather station can measure the wind speed, the precipitation, the temperature, things like that. And a person doesn't need to be sitting there monitoring that. And that's actually a lot of the weather that we do have reported to us is measured using remote locations, and a person doesn't need to be there. So what can we measure? We can measure distance or length, time, temperature, volume, capacity. So volume would be like a water bottle, right? So that is the how full something is in 3 dimensions. We're going to talk a little bit more about volume in a second. Distance and length, that's a pretty common one. Time, temperature, and then we can also measure mass. Sometimes we refer to it as weight, but it's a little bit different. Common tools that we use to measure, we've got a triple beam balance, a ruler, a regular digital balance, some Erlenmeyer flasks, graduated cylinders, beakers, and also thermometers. So these are things that you might see throughout the year. You'll definitely see them if you take some other science classes, and you've probably seen them all before. So density. Density is how compact something is. So usually when you pick up something that's very, very dense, your like gut reaction is probably going to be, wow, that felt heavier than I was expecting it to feel. So some examples of that might be, anybody's ever gone fishing, the little sinker that you put on, the little weight that you put on your line to make that line go towards the bottom of the lake or pond or whatever it is that you're fishing in. That's something that's very, very dense. Something that's not very dense, lots of gases are not very dense. Anything that floats in water is not very dense. In terms of like pieces of wood and things like that are going to be less dense things. That just means that whatever it is that's inside the types of atoms or whatever that material is made up of, they're either really squished together or they're not as squished together if we're talking about solids. And we can talk about density. Liquids are less dense than solids a lot of the time, but not always. And usually gases are less dense than the other two, but again, not always. So an intrinsic property is a property of an object that has in itself no matter what. So this means that I can slice something up, like a chocolate bar. All of those little pieces of chocolate are all going to have the same density, but they're just in smaller pieces now. So we're keeping the ratio of mass to volume the same, which keeps their density the same. And you guys did this probably last year in 8th grade science. So density is a measurement that compares the amount of matter an object has to its volume. So if the amount of matter is squished into a smaller volume and squished into a smaller space, it's going to have a higher density. If you're not trying to squish as much matter into a given volume, it's going to have a lower density. So an object with a little bit of matter, but the same amount of volume is going to have a low density compared to an object with a lot of matter in a given volume is going to have a larger density. So down here, these pictures are what it would look like if we had a couple different materials, and those materials either are very concentrated with their atoms or molecules that are in them, a little bit less concentrated, and then more concentrated. Usually we would refer to material A, that is probably going to be a solid. Material B, most likely a liquid, and then material C, most likely a gas, where those molecules and those atoms can spread out a little bit better in a gaseous state. So how are we going to calculate density? And this is something that's on your reference table, and we'll talk more about that. But this measurement being on, or this equation being on your reference table, it's right on the front page. There's a little box that says equations, and this is one of the ones that are in there. So we need to know how a substance's mass and volume, how those are related together is going to be its density. So density equals mass over volume, so M over V. Mass is the amount of matter in an object, and volume is the amount of space that that object is taking up. So there's a couple different rearrangements depending on which information we have. You can always rearrange that equation to look a little bit different. Say you have mass and volume, you can use that first one. If you have density and volume, you can use the second one. And then if you have mass and density, you can use that bottom one that says equals V. So this is what we're talking about in terms of layering by density. So this layering up of things, liquids, solids, whatever it might be, they're layering because of their density. And this is going to be a common theme. This is how our layers of the earth are organized. They're set up from most dense to least dense. And that's exactly what's happening in this tube. So that bolt that's made of metal down there at the bottom, that one is going to be the most dense thing because it's sitting on the very bottom. That ping pong ball, because it's full of air, is going to float, and it's floating on that lamp oil, that red layer up there. And that lamp oil is less dense than the rubbing alcohol below it, is less dense than the vegetable oil, and then the water. So that lamp oil, if we're talking about liquids, is the least dense liquid, and then the honey down at the bottom is the most dense liquid. So most dense things, if we're trying to layer things up like this, or if we put everything all in the same space, it's going to layer like this because of these objects' different densities. A little bit of graphing review. There are many types of graphs. Usually in science, we use line graphs. This is an example of a line graph. We can look at, it's a comparison of funds or money over different years. And down there at the bottom, there's a little key. And we've got year 2016, 2017, 2018. All right, so graphing review. The independent variable is always on the x-axis. You can use mix to remember that. Manipulated independent on the x. The thing that I control or I am changing. The dependent variable is always on the y-axis. And you can use the phrase dry. Dependent responding y-axis, right? So that's where that goes. The thing that responds to what it is that I'm changing. So in an experiment, there's something that I can control, and that's what I'm controlling. So if I change what I'm controlling, the thing that's going to respond to that change is what the dependent variable is, all right? We'll do more with this. This you might remember from middle school. Some of your teachers use this. I prefer it. I think it's easier to remember which goes where when you use mix and dry, which is your y-axis, which is your x-axis. And then also tails, graphing with tails, title, axis, interval, labels, and scale makes things really easy to remember in terms of what should be a part of your graph. So that title, graph with tails would be our title up there. The axes are labeled with their particular labels, and we have two different axes. Our intervals, if this was actually showing you data, intervals would be how whatever it is changing. So if I have all numbers that I'm graphing between 1 and 10, my intervals don't need to go from 0 to 100. That would make my graph really squishy at the bottom, and we don't want that. We want to spread out our data so we can see as best we can. Reading relationships from graphs, direct relationships are going to have a positive slope, right? Indirect relationships, a negative slope. No relationship, just flat line. And then we can also have things that are a cyclic relationship. And this is what we're going to be particularly concerned with in earth science. We're going to look at a lot of different cycles. Temperature is one that's pretty common. You can see that throughout the year, usually we expect the summertime to be warm. We expect the winter to be cool. So if we graph something like that and we graph a couple years, it's going to go up and down because of that relationship between those two. And that's all I got for you.